Welcome to this presentation, dear all. Today, I want to define general surface of revolution with an example. I will show the minimum surface with the help of mathematics. So, a surface generated by the revolution of a plane curve about an axis in its plane is called a surface of revolution. For example, x minus 2 whole square plus 1 is just curve 1 less than x less than 4 is a curve in a plane surface. Let us take x-axis is the axis of revolution, and let the generating curve in z-axis plane y equal to 0 is given by. With the help of geogebra, I will show you about the surface of revolution. For that, first of all, by taking x minus 2 whole square plus 1, where 1 is smaller than x is smaller than 4, sorry, 4. Yes, you can see the curve here. Then we need the surface of revolution. Surface of revolution, so f n x axis axis. Okay, you can see that the revolution some part is shown here. Then we'll fix the scale for 0, 2 pi, this 0, 2 pi, and 5 divided by 180. Then you can see this revolution, surface of revolution, that is the definition. We can see this, and even we can move this surface as well. Yes, in different direction we can see the surface itself can rotate. Also we can rotate this also in different side and different um, from different side we can observe this. This is the surface of revolution. It can be it can dance. Yes, we can dance this. Yeah, so this is surface of revolution. That the figure is the moving. Yes, this is surface of revolution. Interestingly, we can observe this is the surface of revolution. A curve which is revoluted, and it makes the surface of revolution, which makes the surface which is the surface of revolution. Now, I want to show the minimal surface with mathematical plot. For that, I have already prepared a minimal surface. Here you can see the, first of all, define a function. We have to define the function f of x y z equal to xy log cos y minus cos x. I have taken this example for the minimal surface. Then I have to find the r1 derivative with parametric derivative with respect to, yeah, x. You will obtain this. After that, I have to find r2 derivative with respect to y, and then r11 first derivative with respect to x, again with respect to x, r11. I think you know this also. R12, r22, and simply dot of r1 r2. Here e is not taken because the mathematical clause, if we keep here e, then there is something wrong. That's why I use k instead of e. we find E also here. Sorry. And then F also R1 dot R2, that is minus 10x minus 10y. Then G, simplify R2 dot R2, you will get sec square y. Then we know h square equal to Ez minus f square. With the help of this formula, we can find h, which is shown by this way here. After finding h, we have to find n. Here a is used instead of n because it has the same problem. Then we can find L. We plot this way about the L. Then we can find M. We can simplify. Then we can find N. Here I use N dash instead of that N. So we can find this also. And finally we have to find the mu, which means En minus 2Fm plus Lg divided by h square. It should be 0 to be the surface is minimal. That's why I use this formula and I obtain 0. Therefore mu equal to 0, so the surface is minimal. Thank you. Anyway, if you want to know the plot, I have shown here slowly. You can pause it and you can study and you can try, dear friends. Thank you for the patience, dear all.